Okay, I think it's recording. Okay. So give two names for the line. You can name it however you want. There's actually several ways you could name it. You could say JL if you want. Just make sure you put that symbol up above. You could say KM. Uh, are there multiple ways? Yeah. You can say JK, you can say KL, you can say LM, MJ. There's so many ways you can name it. So bottom line, no pun intended. You guys got that? Okay. That was not intended totally. Okay. Dumb dad joke. Um, the point being, okay, that's another pun. Get that too? All right. Keep coming, right? Okay. What I'm trying to say is that pick 2 points, and that's all you need to do. And put this symbol up above. That's all you have to do. Okay. Now, two segments, same thing. You can say JK and KL, right? So there you go. Two rays, you can say KJ, but you have to put that little symbol there, right? Like this, like an arrow. Or you can say, I don't know, LM. So yeah, that's all. Opposite rays, you have to be careful with that one. You say if you're to say KJ, K is going towards J, then I would say KL. K is going towards L. So you have the same endpoint but opposite directions. So, and again, there's like multiple answers. You don't have to have exactly these answers, just multiple answers. For number two, I'm just going to kind of do it quick, and then we could simmer on it a little bit. We're going to say false, true, true, false, 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 true, true. Okay, so false, true, true, false, 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 true, true. Um, Questions on these at all? Just keep in mind C is not between A and B, right? That's totally obvious, right? Because C, A, B don't make a line. AD and AG are opposite rays because they start with A and go in opposite directions. CB and BC, if they're segments, doesn't matter order. The order does matter for rays because they have different endpoints in different directions. For 9, that's oh wait. Oh yeah, that was tricky. BC is a ray, CB is a line, so that's a problem. And for 10, right, a segment and a line, totally different. 11, yeah, they're on the same line. They go forever. They're not the same segments, but definitely the same lines. And then fine for 12, yeah, both start at the same place and go in the same direction. So, all right, cool. All's good there. Okay, now let's move on to 13. So the midpoint. So how long is AE? 8. And what's half of 8? And what's 4 away from either A or E? Correct. So you got to meet right in the middle. So 1 is correct. Good. This one you should get X equals 5. Right, that's pretty simple. And then this is course 9 and 5. That's super easy. Make any corrections, of course, if you make a careless mistake, it happens. But X plus 4 plus X equals 14, right? So that's the setup, and then you solve it, and you should be A-okay after that. For number 15, that one should be X is 12. We're agreeing with that. Yeah, if X is 12, then of course that's 6. That all makes sense. Okay, 16. Did anyone find that a little weird? Yes. And why is it weird? Weird is good. What did he, was it factorable? No. Yeah, I used quad form, unfortunately. And I don't know if that was the intention, maybe because we are talking about quad form today, so that might be a nice little segue to what we're doing today. And this kind of gives you a little bit of a sneak peek of the pretest coming up today. Um, but first of all, you're going to set up like this. I do promise you that when we give you these kinds of problems with geometry, we're going to make sure. Well, I mean, if it were to involve quad form, I think you would be aware of that. But usually we want these to be factorable. Because if you think about, first of all, two parts make up the whole. JK and KL make up JL, right? That's pretty obvious. If you go through the motions of the algebra, you should get this. X squared plus 3x minus 6 equals 0. And here's the problem. So for those who had algebra one, and I know you guys use CPM. Did you guys like factor using this method
Yeah.
Yeah.
and this as well? Yeah. So A times C, the A value, the coefficient of x squared is 1. The C value is -6. So combined, that's -6. B, the middle coefficient is 3. Are there two integers that multiply -6 and add to 3? No. I mean, -1 is 6, -2 and 3, and that's, or you reverse them. That's it. So unfortunately, this is not factorable. So in this case, you could do a couple things. You could do quad form. Did you guys learn completing the square? Okay, so you do completing the square also. If I do quad form, you should ultimately get this. -3, that's your negative b, plus or minus b squared minus 4ac. That will be 33 inside the radical, if I'm not mistaken, over 2a. So there's two possibilities. However, one of them is physically impossible. Y is -3 minus root 33. So if I got rid of the plus here, why would that be physically impossible? Go ahead. Yeah, how can you have a negative length? That makes no sense, right? So thank you, Allison. Yeah, you go by Allie, right? Yeah. So yeah, that makes no sense, right? But plus is okay. And I know the plus is okay because is root 33 higher than 3? Between what two whole numbers would root 33 be located on a number line? What's root 25? What's root 36? So it's between 5 and 6, right? Exactly. I don't know. Is it 5.5, 5.7? I have no clue. But what I do know is if I add to -3, I still get a positive numerator. Divided by 2 is still a positive value. So that's the only one I could go with. Don't bother trying to find JK and KL. That is just crazy. You solve for X, that's cool. If you to throw it back into here and here and to figure out JK and KLR, that's just silly. So don't worry about that. But if you at least you saw this, that's cool. That's good. Okay. So we're all good on that? Okay, great. So let's start the pretest. So the pretest is going to be just a bunch of algebra. There's some factoring, there's some solving by factoring, some solving by quad form. There's some radical stuff, other equations, there's system of equations, find the equation of a line. So again, just for us to see what you guys know. Don't worry if you're stuck, it's okay. But the hope is, after the next 2 weeks, we feel better about these things. So here we go. If you do need a calculator, that's okay. I might have some calculators in the back on full function calculators. If you have your own, that's cool too. The only thing I ask, and I'm just for just sense of integrity, don't use the calculator to graph stuff.
What?
So just use it for calculations.
Wait.
But if you have a four function, obviously you're just good for complications. Good, here we go. I'll come advanced game with full here.
No, hold on.
And time wise, we'll go close to like 9:40-ish or so. We'll see. If you have questions, ask it. What's up?
Um,
Platform?
Yeah.
Yeah, actually, I'll provide platform for you guys because we do that. Not a problem.
Thank you.
This is
No.
right here. Yes,
Yeah.
yes, correct. That's the actual form, and of course that's worked out in red. Yeah, go for it. Of course, yeah, go for it. We'll probably spend about 10 more minutes on this assessment. Well, I'm just gonna do a quick scan of your last assessment. Probably spend about maybe 6, 7 more minutes on this. Oh, I've been recording this whole time. It's stupid. That's so dumb. Okay, cool. So yeah, so let's go over the answers for this geometry pretest so we can be better at this stuff, right? So for number one, a five-sided figure is a pentagon. That's F. A quadrilateral of 4 angles. That's just going to be a rectangle, right? Rectangle have four right angles. If it has 4 sides, you can't say it's a square just yet. You can say it's a rhombus. So that's I. A four-sided figure, and we reviewed this obviously yesterday, right? A four-sided figure is J, which is a quadrilateral because that's just very general. A quadrilateral, 4 sides and 4 angles, that's very special now. It's like the rectangle and rhombus combined. That becomes a square. That's D. 8-sided is octagon. It's H. Quadrilateral with 1 pair of parallel sides. That's a trapezoid. Quadrilateral with 2 pairs of adjacent equal sides. That's going to be C, a kite. Quadrilateral with 2 pairs of parallel opposite sides. It's going to be G, a parallelogram. And a 6-sided figure is a hexagon. And I think we did talk about this yesterday. I think I did go over this. Now I'm starting to remember, but I'm doing it again anyway because I want you to make the corrections. So make those corrections. So FEIJ DHACGB. Okay, and again, I will post this as well to Schoology. So I'll put in a folder called like assessments or something like that, and we'll be there. For number two, next to each triangle, so that's equilateral, the top left, the middle is right. I think most of you guys got that. I think where you guys got mixed up was isosceles and scaling. Isosceles is the upper right because you have 2 sides. Scaling, all sides are different. Acute and obtuse, you can only make those observations if you know the angles. Those are only purely for angle observations. Whenever one angle is more than 90, that's going to be obtuse. Whenever all 3 angles are less than 90, that's acute. Now, technically speaking, isosceles, this one could be acute. I just don't know these angles. I could be right. I have no clue. Right? I don't know anything about that. That's some side links I could probably figure it out. Here, you could figure out the angles if you wanted to. That's probably a little more advanced trigonometry and some geometry skills, perhaps. I think this is acute regardless if you were to work it out, but still. But this is how we classify it. One quick question. Do you guys have access to Schoology for previous classes? Okay. Oh, you don't? They remove it? Okay, so what I will do, I'll make sure because they'll remove the Schoology page. They'll archive it. I get access to it because I'm a teacher. I think once school starts, I'll make sure I'll make a Google Drive for you guys so you have access to this throughout the school year. Because all the stuff I'm going to be putting in Schoology over the next 2 weeks, I want to make sure you still have access to it. So I will make a Google Drive to share with you guys. And I'll share with your SH School's email address. Here, I thought this was fine, but remember a line segment. Now you know from the homework. You got to put that little symbol that's just a bar and any 2 points you can give, right? That happen to be on a line. You wouldn't say JS, but you could say JO or OE or something like that. ER, that works for array. They use that symbol there. A line has to have the 2 arrows, right? Has to have 2 arrows. 6, I thought you guys were good. You guys need to point out where they touch. Collinear. Co means the same. Linear means line. Same line. Like a co-pilot, right? What's a co-pilot? You have 2 pilots who both fly the plane, right? Co-captains. You have 2 captains that lead the team, right? So co-linear, they're on the same line. So JOE are not on the same line. Clear they're not. So that would be no. This was pretty good. Number 8 was 8. That's just the length of AR. That's pretty straightforward. The midpoint GR, I put 10 because I didn't read the question carefully. I thought they wanted the length. Of course, it's the midpoint. So halfway between G and R is -2 or T. Either works. And GA plus AT, GA has length of 2. AT has a length of 3. Or if you count it from G, 1, 2, 3, 4, 5. And you always get a distance as a positive value, never as a negative value. Always as a positive value. So GA plus AT is 5. This one, we haven't learned this stuff, so don't worry about it. You will learn it eventually. Acute's less than 90, so any angle less than 90, EIP would be a great example. When you name angles, you have to give 3 points, and the middle point has to be the vertex, the sharp corner. So also to think about, this is a good discussion of angles. It's 2 rays connected by a common endpoint. IE and IP can be rays, right? And both those rays form an angle at point I. So you always want the middle to be the vertex. ZIS is going to be right angle plus 90 degrees. ZIS, ZIS. So you're going to be very particular about the order. ZIS, 90. I guess at SIZ, that would be the same thing, still 90. There are other ones that are 90 as well. EIZ or ZIE is 90. You can say that. KIE, because it's opposite this one, that can work with EIK, or KIS, SIK. Obtuse more than 90, PIS would be a good example. PIS, 30, 50, 40, out to 120, that could work. Straight angle is just a line. So you have to still get 3 points. EIS can work, or KIZ, or PIT. Any of those can work. That's what a straight angle is. A straight angle has to be just straight, 180 degrees. This symbol, hopefully, well, I don't know if we talked about it yesterday, but you know what this symbol means? We have it looks like a T, upside down T, like this. Perpendicular. Whenever you're perpendicular, you're forming a right angle. So a street intersection, like for example, Valparaiso and El Camino, that forms a right angle, right? So those are perpendicular streets, right? Like now we run parallel to Park Avenue, right? Because Park Avenue goes this way by Circus Club, and here's Valparaiso, right? We're perpendicular to Elena and Elm, right? So right angles. So that's what right angles are. They have to be 90 degrees. So ZI and IS, 90 degrees. EIP, okay, complementary and self-explanatory. This is, I know you guys haven't seen this, and don't worry if you didn't know. Complementary means 2 angles add to 90. These add to 90 degrees. These add to 180 degrees. So, yeah, let's look at where that happens. EIP is 60, PIZ is 30, so those two add to 90. Supple means add to 180. EIP is 60, PIS is 120. Those add to 180. If you look at the diagram. One way to help me remember when I was learning this many years ago, like some people get these confused. They figure which one's a 90, which one's 180, and that will happen. Trust me, like when you guys come in for office hours and we have tests on this stuff, and one way or another, you're gonna have me or Mr. Davidson, right? And we're gonna co-teach. We're gonna teach exactly the same way, right? And you're gonna come to your office, you're like, I forgot, I can't remember. One way to help me remember, this sounds like supply. We have a supply of something, you have a lot of something. I mean, you can have a low supply, I suppose, but if you have a stockpile or supply of something, so that should be the bigger one, 180. That should be the small 190. So complementary means 90, supplementary means 180. 18, 19, most of you guys are pretty cool with that one. KIT, you're able to identify that's 30 degrees. That's because it's opposite this angle here. Those be identical. That's for KIT. For SIT, geez, hold on. SIT was 60. If you look at SIT, where the heck's SIT? Yeah, right here. That's opposite this one here. So that's 60. And lastly, TIE. So TIE, that's 120 because that was 30. That's a terrible looking 3, sorry, and that's a 90. So that's with the 120. So but that's because that's 60, 30, forming a straight angle. So you got that. Parallel means this same direction. I think everyone got that one. They don't touch. Perpendicular right angle. So right angle like this, like a cross. Okay. There you go. Right angle. Right. It's all around us here, this campus. For 22, congruent just means equal in measure and shape. And so all corresponding angles of sides would be identical. So if I drew this and drew another one that's exactly the same shape and size, great. That's congruent. Similar means just the same shape. So it's like if you ever go to like a hobby store and like you try to build a model airplane or something like that. Only reason I mentioned it because I took my kids there on the weekend. And they have like these these replicas of like maybe a World War II ship or an airplane, whatever. Of course, it's not the real thing, right? Because that'd be like hundreds of feet. But yeah, but if you look at this, yeah, that makes sense. Like that's just they're proportional, right? So maybe like this is a 1-to-3 ratio. Like if that's 1, 2, 3, actually, if that was 2, 3, 4, it's gonna be 4, 6, 8, something like that, right? So it's just proportional. Um, area and perimeter. So you guys are on the right path. Perimeter means the distance around something. So if I want to find the perimeter of this table, I would take a measuring tape. I say that's like 3 feet. That's like 2 feet, 3 feet, 2 feet. Okay, so it's 10 feet perimeter. Area. How do I find the area? I still take my measuring tape, but when I have the length and the width, what do I do about that? Times it. Because it's about space. Area is about space. Like this campus has a crap load of space, right? Especially this building. You should have seen the previous building. This is like 5 times the space. How do I know that? The square footage. Your house has square footage, right? If you have a big house, you have a lot of space. But perimeter is just the distance around. And lastly, I know people are taking a break. It's 10 o'clock. Here are the formulas. Length times width is rectangle. Half times base times height is triangle. Just base times height for parallelogram. Trapezoid are those. We're going to do diagrams of these when the time comes. Pi r squared is for area of a circle. 2 pi r is circumference. That's the distance around a circle, is 2 pi r. But for a parallelogram, just so you know, it looks like this. We call that B, and you call it H right here. Where for a trapezoid, we'll call this B1 and B2, and the height. B1 and B2 are interchangeable. Doesn't matter which one you call it. You can call it top one B1, bottom B2. Doesn't really matter. So anyhow, it's 10 o'clock. Let's take a break. Let's come back at 10:10. All right. And I'll post this to Schoology. So, and this is for you guys to keep. Yeah, feel free, guys. Now, oh, okay. Now we're recording. So again, when we want to factor, we like to do figure out A and C are and B. We do A times C up top, B down below, and generally a quadratic expression is written as AX squared plus BX plus C. So for number 1, if you don't see a number in front of X squared, what do you assume it is? 1. And what's B? 8. And what's C? 7. So A times C, 1 times 8 is 8. 7's down below. So I put 8, sorry, 7. Sorry, I really just messed that one up. A times C, 1 times 7 is 7, and 8's the middle term I put below. So 7 up top, 8 down below. My apologies. Now what you have to do is find 2 numbers that multiply multiply to AC, and add to B. Two numbers that multiply AC and add to B. So what two numbers multiply to 7, add to 8? Go ahead. Jake. 7, 1. That's it. And that's the only option I got. I got no other options. Now, fortunately, because whenever A equals 1, you can go straight to the factor form. X plus 1, X plus 7. You don't have to do like that box thing. I know some of you guys do this. I'll change colors for a bit of contrast. I know you guys do this, which we will do on the next page for sure. So you put the leading term here, and you put the last term here, and then you put these two numbers here and here. But what this diamond thing, we call it the diamond here. This is we call this a diamond. It looks like an X or a cross, but we'll call it a diamond. The diamond method. This is actually referred to as splitting the middle term. What was my middle term in the original expression? 8x. And how do I split it? As x and 7x, right? Because what's x plus 7x? 8x, right? So by doing that, what would I multiply to get x squared? X and x. And then what would I put right here? A 1, right? Because isn't x times 1x, right? And then what would I put right here? 7. Boom. So x plus 1. So you don't have to do that because once you do this, it's back right? Only when A equals 1. When it's not 1, then we need to do this or something else. There are other methods too. Has anyone heard of like something called the Russian peasant method? Okay, good. Then don't or I don't know why it's called that actually. Someone mentioned that. I was like, okay, what do you mean by that? And it seemed really backwards to me. I don't know. The bottom line is this: we want to avoid too much guessing and checking. You could guess and check, you could, but are you going to guess and check with something crazy like these here? I wouldn't. So we want to minimize that opportunity or minimize that chance. We want to have a method that's organized and logical, right? That has some sort of methodical. That's a better way to say it. We want a methodical process. So let me do 6, and I'll have you guys try 2, 3, 4, 5. Okay. What's my A value here? What's my C value? So I put 40 up. What's my B value? Okay. Now 40 has definitely quite a bit of factors. And sometimes we get kind of stuck mentally, like, okay, what two numbers multiply to 40 and or add to negative 13? Seriously, if you ever get stuck, just start writing the pairs of numbers that multiply to 40. They're not that many. And start low. 140. No, that adds up to 41. What's the next pair? 2 and 20. I get warmer. Can 40 be divided by 3? No. How about 4 and 10? We're really close. What's the next pair? Ah, okay. But should I make both a negative?
Yeah.
Yep, and there you go. So if you ever get stuck, please, please, please be methodical. Mathematicians think methodically. This is the reason why mathematicians and English majors were so different people. English people are thinking about like all the things in the world, like all the different ways of interpreting a novel or whatever, and their mind just flows. We are not that way. I'm like, boom, boom, boom. Let's go in order, right? We gotta be methodical here. So we gotta because if you try to think of like all these different numbers, you're gonna drive yourself crazy. Be methodical, you'll hit the numbers. So it's n minus 5, n minus 8. That's the mindset we need to have when we do this. Okay, go and try the other the other 4. If you've kind of got ahead and you want to move on to page 2, you can. But let me give you guys probably 3-ish minutes, and then we'll move on to page 2. And when you get really good with this, if you just know the answers, by the way, You look at it, you just know, hey, I'm not gonna hold that against you. That's all good. You just know it. Because when you get really good at this, you could just do, very quickly. All right, let me show you my answers. Here we go. Hopefully got that. One way to always verify your work is use a process called FOIL. Have you guys heard of the FOIL process? What does it stand for? Do you know?
Works.
Outside. inside. I'll be honest, I didn't know what it meant until I started teaching. So don't worry if you don't know. I just, oh yeah, FOIL. Okay, well, and I didn't know it was an acronym, right? It is first, outside, inside, last, right? Because if you were to, and thank you, Wagon, for sharing that. Yeah, because if you were to multiply W with W, you get W squared, negative 4W, 6W, and negative 24. So first, actually, here's the first, here's the outside, here's the inside, here's the last. So that's what's called the FOIL process. Jacob?
Does it really matter the order of these?
No, it does not. No, no, it doesn't. All right, so now let's get to more challenging factoring. Now here, A does not equal 1, right? A does not equal 1. So let's do 7 and 12, and I'll have you guys try 8, 9, 10, 11. So let's start with 7. What are my A and C values?
85.
Great. Yeah, be careful. What was it? Sorry? What's the second handout? Oh, you're not gonna have time to.
Well, I don't know. I'm just checking on your time.
Okay. I, I don't know. We'll see. I think I'll probably maybe not the equations. Maybe some. Yeah. Yeah. Okay. So what's A times C here? Negative 15, right? And what's my B value? Okay. That is terrible. I could do so much better than that. Well, negative 15 and negative 2. Cool. Okay, what two numbers multiply negative 15 add to negative 2? Perfect. Negative 5, 2. Love it. Okay, so now I'm going to do a box. Totally gonna do this box method now. I'm going to put the first term in the upper left corner, 3x squared. The lower term in the lower right corner, negative 5. And remember, what this represents, this is actually negative 2x. It just splits. The diamond helps us split the middle term. So we're really reducing. The only trial and error, to be honest with you, was this. Just find the pairs. There's not that many pairs. Negative 1, 15, negative 3, 5. That was it, really. Or reverse the signs. That's it. So negative 5x and negative 3x. Okay. What I prefer to do first is to figure out, hey, what can I pull out of the first row here? What did these, so we call this the GCF, which stands for greatest common factor. What's the greatest common factor between these two here?
9.
The greatest common factor, not multiples. What do they both have in common?
3.
And x, good. Common, right? What they have in common. So 3x. Now, what do you multiply 3x to get to this guy? X, that's just algebra, right? That's x. Cool. Now, what do you multiply this x to get to this guy? Negative 5, yes, good. And then lastly, what do I multiply negative 5 to get to negative 5?
1.
Wait, I just messed up, didn't I? Wait,
Hold on.
hold up. What did I do wrong? Oh, okay, I made a careless mistake, guys. I made a careless mistake. What mistake did I make? That should have been positive 3x. That was my mistake. My apologies. That's why I was a little off. But I caught myself. I'm a human being. I make mistakes. Right? I'm not perfect. Okay. I try to be perfect, but I'm not. And you know what? But I know my math. I know my math. I'm 47 years old. I've done this for been to college and I've done all this stuff, right? So what I do is I tell myself, hey, I'm human. I made a careless mistake. I'm not doubting my methods. I just made an error. And so don't doubt yourself. You know this. You're human. You're gonna make mistakes. We all do. I just did it right now. So anyway, don't never doubt yourself. Put it that way. Always have faith that you know what you're doing. Just you might make an error. It happens. So you got x plus 1. And it does check out. Okay. Let's do 12. And then we have you guys try 8, 9, 10, 11. So let's do 12 next. Okay. The first thing you should do, actually, I should have said this earlier. I should have looked for the Grace factor before I got to the diamond. Should always do that. We will need to do that, I think, for number 11. What factor is common among these three terms for number 11? 9, 20, 6, 6. So you got to pull it. I would pull a 3 out first. You don't have to. Ultimately, you're going to have to at the end, but you're going to make your life much easier in smaller numbers. You want to do 9 times 21 in your head and 6, 6 and figure out those pairs? Good luck. Don't do it. Anyhow, for 12. You have a bunch of negatives. Negatives are also kind of nasty too, right? I probably should take negative out first. So let's take a negative out first. I'll put -1 on the outside. I'll have 6v squared minus 25v. Sorry, plus 25v, because I have to pull it negative, duh. Plus 25. A times C. 150 and 25. By the way, if you need a calculator, it's totally okay. If you can't do 6 times 25 in your head, it's okay to use a 4-function calculator or scientific, totally fine. 6 times 25 is 150. Your B value is 25, right? Now, let's look at the pairs. What two numbers multiply 150 add up to 25? So 1 and 150, no. 2 and 75, no. 3 and 50, no. 5 and 30 getting warmer. What do you guys think? 10 and 15? Yes. 10 and 15 should work. Multiply 150 up to 25. And why are we doing this, by the way? I mean, it does become a very dry, boring process. But when you do move on, you gotta trust me on this. When you move on to pre-calculus, like you guys are in geometry next year, so algebra 2 is not for another year after that. And then pre-calculus, and then maybe calculus in college or here as a senior. Yeah, we want to make sure that you can handle the advanced math because this is a skill that needs to be second nature when you get to the more advanced problems. When you get to the more advanced stuff down the road, this can't be an issue because you'll have a hard time learning the more advanced stuff if this is an issue. Like I've taught calculus students who couldn't factor. I'm like, well, I'm not sure how to help you because you're stuck in this one part, right? So we want to make sure that we're comfortable. So in pandemic, I definitely blame pandemic for a lot of that. That was a big thing a few years ago, but anyhow. So 6v squared, 25, 10v, 15v. What can you pull out of the first row? What do they have in common? And 3, because 15 can't be divided by 2. Now, what do you multiply 3v to get to 6v squared? Good, awesome. Thank you, Natalie. 2v. And then what do you multiply this one? 5 and 5. And I don't think I made an error. So you have a negative on the outside, 3v plus 5, and 2v plus 5. And it will all check out. And again, these are skills that we just need when we get to more advanced math down the road, like in calculus. Hey guys, we got to factor this. Let's factor it. And also just to understand x-intercepts too. There were problems that involve this kind of modeling that are modeled using these kind of equations and understanding, context like in physics. If we throw something, it follows a parabolic path. When it hits the ground, that's an x-intercept. There's a lot of applications to this too. So factoring does play a big role in a lot of stuff you do down the road. Some people disagree with it, but I disagree with them because I think this is important. Let's do 8, 9, 10, 11. Let's go for it. 8, 9, 10, 11. Take a few minutes. Then I'm going to briefly talk about the third page and we'll talk about radicals after that. Might be a little hard to do this in your head or trial and error. So I definitely want you guys trying. Let me undo. There we go. I'm actually trying to do this in my head, which is not smart, but see here, it's 9. Okay, I'm gonna show you the answers. Are you guys still working? Yes, no, kind of. So I didn't do the diamond. I actually literally did these in my head, but if you did the diamond, you have -18 and 3 here. You'd have 10 and 11. You'd have 140, 196. Jake, what?
That be on number 7, 3x?
3x. Hold on.
Yeah.
it's- Wait, that's probably that's number 8.
That's number 8. I'm doing number 8.
I do.
Yeah, no, I'm doing number 8. We already did 7. Anyway, for this one, that's gonna be, oh geez, 146, 196, and 53. And that's 494, I think. And that one would be, after you pull the 3 out, that'd be 21 and 22. So 1 and 21. Yeah. And of course, that'd be 1 and 10, 6 and -3, So yeah. And then of course just do the box, all that stuff. So in just a time, let's not do all 18, all 60s on the third page. Any questions on 8, 9, 10, 11? Okay. I say let's do 13 and 17 because 17 looks a little crazy. Crazy is good. So we'll just do 13 and 17 together, and then we'll move on to the radical stuff, and then we'll wrap up and right before 11 o'clock today. So we won't get to all these problems today. Now let's take a look at 13. You're asked to solve by factoring. So what's happening here? You have to get all the terms on one side. Very, very important. Let me write this down. Before you factor, you must get all terms on one side. Very important. Before you factor, must get all terms on one side. Okay. The reason why you're doing this is that you're trying to find you're actually finding x-intercepts. That's what you're doing. Because if you were to graph this, the graph looks like this. Did you guys graph parabolas or quadratic functions? Yeah, okay. So you guys did. So yeah, so you have like these x-intercepts, right? And that's what you're doing. You're letting this equal y. You want to see where it crosses the x-axis. So when it's factored, it's easy to find what makes them zero because anything times zero is zero. So this is called the zero product property because you're looking at what multiplies as zero. Product is multiply. And in order for a product to be zero, one of the numbers has to be zero, right? You need zero somewhere along the way. You're multiplying a bunch of, I can multiply millions of numbers. If there's just one zero, the whole thing's zero, right? So that's why we factor, because factors are quantities being connected by multiplication, right? Right? Aren't these two sets of parentheses connected by multiplication? If one of those two things is zero, the whole thing is zero. That's what I want to do. So what two numbers multiply 24 and add to negative 11? Multiply 24 and add to negative 11. What two numbers would that be? X minus
8.
Right? Correct. So these two things do these two things multiply to this? You bet. These two things definitely multiply this. If I FOIL, if I first outside inside last, I get that. Now, one of these two things has to be zero. What would make this zero here? What would make this zero here? Oh, the second one. 3. So as long as x equals 8 or 3, we're cool. Now, what happens that we do follow this recipe, right? Oh, just go through the motions and we just try to memorize it. No, we have to understand what the heck is happening graphically. If you graph that, if you went to Desmos and graph that, where is that going to cross the x-axis? At 8 and 3. Why? Because it makes this zero. Because y equals 0. That's why we do this. So this right here, x minus 8 equals 0. So x equals 8. Because if I plug in 8 back in the original equation, it's going to work. You get 0 on the left side equaling 0 on the right side. And here, same thing. But very, very important, you have to get all the terms on one side so that you can use the zero product property. And either x could equal this or it could equal that. Zero product property. That's exactly what's happening here. We could do this 5 more times. I don't think that's the best use of our time because we have some other things to talk about in a moment. But let's do 17. I'll kind of give you guys a little head start. Let's move all terms to one side. Ah, geez. Okay, work out the rest. Should be pretty simple after that. Notice I got everything on one side, move -3 from right to left, move 11x from right to left, got -55x and plus 150, pull the 5 out, common factor, get it out of the way. So you have a 5. And what other two things are being multiplied to the 5? So what multiplies to 30 and adds up to -11? What do you guys think? 6 and 5, yeah. Good. 6, 5, yeah. Great. Awesome. Good work. X minus 6, X minus 5. Awesome. Good work. Now, what does this mean? Right. Because here's the thing. I've taken this and broke it down into a product of 3 quantities. 5, X minus 6, X minus 5. 5 times this has to equal 0. Well, 5 is 5. What do we do? I can't do anything about that. It's 5. But I could change this. Why do we call these variables in the first place? Because this has the word vary. Exactly. Vary means a change. Do whatever I want it to be. I'm gonna make it 6. Great, it works. Or I can make this 5. Great, it works. Those are my only two options to make it work. So x must equal 6 or 5. That's it. X equals 6 or x equals 5. So that will make the equation true for number 17. And this is, in a way, it's a proof, right? Because we're proving why x must equal these two values to make this work. So that's how I would solve that equation by factoring. You could do quad form if you like. You can. It's just a pain in the ass because those are large numbers and the quad form, it's right there. It's kind of crazy, but yeah. Okay. We could do the other 4, but I think in the interest of time, we've got about 10 more minutes. And I do need to talk about another topic with you guys. I'm gonna have to rush it a little bit. Something that you guys have seen before, I think. Tell me if you've not. I will have a chat with Mr. Donahoe. I'm just kidding. He's a great teacher. By the way, I taught both of Mr. Donahoe's younger siblings many years ago. So. But I never taught Mr. Donahoe. He's a closer in age to me. So anyhow. Okay, simplifying radicals. If we have a chance, maybe I could squeeze in a problem or two on the next page, but after that, we got to wrap up today. Okay, let's take a look at 2, 4, and both 5 and 6. Okay, so I'm going to write this in a text box over here. Let me rephrase that. Square root is when 2 identical numbers multiply to the number side of the radical. What 2 identical numbers? I know it's kind of tricky. We could start with something kind of close. What's 10 times 10? We're getting kind of close. Okay, so I know 11 times 11 is. Okay, good. All right. 12 times 12. Okay, we're getting warmer. 13 times 13.
169.
So that one. Okay. Now, this is where it gets a little tricky to have memorized. 14 times 14 is 196. 15 times 15 is 225. So I'm hoping it's 16. If you had to use a calculator, I suppose it's fine. But 16 times 16 is going to be 256. So yeah. So that's 16. Now for here, it's a little funny because we have variables. So definitely gonna say 4 for sure. Definitely gonna say 4 for sure. Because 4 times 4 is 16, it's obvious. The variables are a little funny. But it's gotta be identical still. Still. What two identical variables would multiply to x4? What do you guys think? What's x times x?
X.
What's x squared times x squared?
6x.
No, x squared times x squared. When you multiply, you're not adding. X to 4. Actually, you're adding the exponents, but not the x's, right? So yeah, that'd be x squared. Okay, what two identical variables multiply to y8? Correct. Because here's the deal. If I were to multiply it by itself, if I were to multiply these together, I would get 16x4 y8. I would totally get that. So 4x squared y4. That's it. Okay, 5 and 6 are a little crazy. Let me look at the homework that we're assigning you guys. We may have to adjust the homework perhaps. Let me take a quick peek here. You know what? Let's forego 5 and 6 for now. Let's move to the equations. Because I want to make sure you can handle the homework for tonight. Yeah. Let's take a look at, and we got about 6 more minutes. We could totally knock this out. Let's take a look at 12. 13. And 15. We knock these two. I think you guys can handle homework for tonight. Yeah. Okay. And remember what to do? You guys remember how to do this? Let's start 12. What should be step number 1? +1, yes. Do not square both sides yet. Do not do that. You are asking for world trouble if you square both sides. You have to isolate. First step, isolate the radical on just one side. Very important. Because if you start squaring both sides, it gets incredibly messy. I mean, don't do this. This is wrong. If I were to square both sides, sure, I get 25 on the right side. The left side, I have to actually multiply √3/2 minus 1 to itself. And that's foiling. And that creates a new radical. You make the problem more challenging for yourself if you do that. Don't do that. So much easier if you just add that 1. So much easier. So now what happens? √3a/2 equals 6. Now square both sides. Now you can square both sides. Because what happens to square radical? Yeah. So 3/2, like √25 times √25 is, or √4 times √4 is √16, which just gets you back to 4, right? So 3/2 equals 36. At this point, you guys should be pretty comfortable with solving it. What would I do to solve after this? Yeah, multiply by 2. So 3a equals 72. A equals 24. And always a good idea to check back in the original equation, especially for radical equations, because if I plug 24 back in, I get 72/2, which is 36. √36 is 6. 6 minus 1 is 5. Yeah. Yeah. Okay. Let's take a look at number 13. Now, is a radical array isolated? Yeah. So should I square both sides right away? Yeah. That's okay. So we get x squared plus 3x So you have that. And what does x equal? Correct. But we got to plug it back in the original to see if it's okay. It will be okay because you get root 16, which is 4, or you get, wait, hold on. No, sorry, you get 16 plus -12, right? That's okay. And last one, 15. Then we'll be done for today. Now you have two radicals on each side. Sorry, one radical on each side. So you have two radicals total, but one on each side. Just square both sides. It's totally fine. And then you should have the answer. It should be pretty easy right at that point. And don't leave before I hand the homework. So make sure you wait. So 5D equals 30. D equals 6. And it should work because you get root 33, yeah. Okay, let me hand you the homework and we're all done for today.
Thank you.
See you guys.
Thank you.
So we got one? Yeah.